Thanks for hanging around this afternoon. So the title of the talk is Real Estate and Information Arbitrage. If you're not familiar with the term arbitrage, it's generally used in commodities trading and stock prices to look at the fluctuation between, the high price and the low price. But in a sense, real estate is a game of information arbitrage because it too is a commodity. And so in this vein, all things being equal, the people who know the things the more sooner or knows it faster wins the game. In the case of location intelligence, if you are a retailer, if you know something about that location, more so than somebody else like your competitor, you're going to get that location first and you're going to win. I stole this from one of my mentors, Gil Castle, who wrote a couple of books, one of the first books on using GIS for location intelligence in business, and then a more recent one on AI in real estate. Okay, I'm going to talk about two probabilistic models, two spatial interaction models. And the first is this. We're at Columbia University. On the side of this podium, it says something about spatial data science, so I thought we'd do a little math. If you'd get out your blue books and number 2 pencils, take a little jot down and we'll go through this. Actually, this model was mentioned earlier. It is the Huff model of a spatial interaction model. And you actually use this all the time. You just don't realize you use it all the time. And you use it particularly on weekends. It is the probability that you will visit one establishment of retail versus another. It clearly was not used by our friends at Kmart as they are closing their last store this month. But it is the reason that you will visit a particular store, and it's based on a couple of factors. And one of them is attractiveness. And you know this, instinctively. You will go to a store because they've got more stock keeping units, more stuff on the shelves. That's why it says stuff. It could have your brand of peanut butter because the other place doesn't have your brand of peanut butter. But it also could be something like it has more parking spaces. It has better lighting in the parking lot. It's a bigger footprint. You may go to Ace Hardware versus a Home Depot because it's closer to your house. And that's where the convenience factor comes in. That's where the D factor is. Okay, that's distance. The fact is that this is used all the time by real estate VPs in locating stores, and it's been used for many years. Huff postulated this model back in 1962. He was a professor of management at University of Texas, Austin for many years. But I know that you look at this and says, Joe, this is a distance decay factor in here. It is a gravity model. I can tell you for a fact it is not a gravity model because Huff told me it's not a gravity model. And apologies to my good friend Julian Lebrun, who mentioned the Huff gravity model earlier. So this is Thursday. I thought we'd do a little throwback Thursday. This is actually a representation of the Huff model as portrayed by the spatial analysis system SPANS, a piece of software developed way back in the late 80s. By a Canadian company called Tydac, who I used to work for. And this is an example of what happens when a competitor moves in to a specific location. And the reason why Huff models were used or other spatial interaction models were used is because retailers want to know what their revenue per square foot is going to be. And if I can tell you that with more authenticity and accuracy, I'm going to win. Going back to our issue of information arbitrage. I stole this too. This came from an article way back in January of 1992 in Forbes magazine. Now, I want you to notice one thing about this article. The title of the article is Geographics. It's not GIS, it's not geospatial. People reading Forbes magazine did not know what the word geospatial meant. And so it was interesting to see how this actually was portrayed. There is a problem with the Huff model, and that is it's based on knowing a store analog. You have to know what is making your store successful, right? So you know what merchandise is there. You know that you've got a stock snow shovels in Sioux Falls and not Sarasota, right? So you have to know what makes your store successful. You have to know what the location is. And those other attractiveness features in an interaction model like Huff were not just spatial, they were aspatial as well, like the number of parking spaces or the lighting in a parking lot. But you had to know what made your store successful. But what if you didn't? What if you had no idea about going into a new area, plopping down a retail establishment? What are you going to use? So this is where I get into an inductive model. So we at CoreLogic proposed a couple of things. We tried to answer the question, what if you wanted to go into a high growth area before it started growing? And what if you wanted to know where there was residential development before ground was broken? Now that sounds like an almost impossible task, but let me take you through it a little bit more directly. We look at things called land in transition, and we look at about 5 key factual indicators on the ground. And it starts with knowing land use codes. So we at CoreLogic are a real estate and property intelligence company, and we've got a treasure trove of data, location-based data in our portfolio. And so we look at whether an agricultural land property goes into commercial, or whether a vacant piece of property goes into residential. And then we start looking at things like building permits and ownership. Well, these 2 factors alone, ownership and land use, may be all you need. That may be the only thing that you care about. But now you add up other things, like I mentioned, building permit data and the dates that those permits were issued. And then you look at things like when a new construction sale was made. You start adding these things up, and things are going to happen on that piece of property before ground was broken. And then you may want to see what the registrar or what the county registrar recorded. They may be recording new postal addresses. They may be recording that the land was platted for a new residential development. So these are the things we look at as the 5 factual indicators on the ground. And as I said, they may be of interest to you alone. And we think that these follow a regular timeline of progression between the time that there is vacant land all the way through to when there is new land use code changes. They may preliminary plat the land with where the homes are going to be located. And then there may be, again, over a period of time, other land use code changes such that you're going from vacant land to something else. And you can see that little chiclet there of a photo shows land under construction. Now, this is not just important to retailers, it's important to telcos who want to go in with fiber. They don't want to have to dig up the ground again. It's something I learned. It's called joint trenching. So when they start putting in the infrastructure, like sewers and electrical lines, they want to go in with fiber. And they just don't want to dig up the ground a second time. So they're looking for these land use changes. And it's important to do this over a timeline that may be anywhere from 12 to 24 months. So they got to know certain things of what's happening on the ground at that time. And then it transitions to things like, okay, what happens if it transitions not from a residential lot, but to single family residence? And that's where you see things changing. Now you see that I've put these things in red and blue. And they indicate the leading and lagging indicators. That's how we divide them up. Such that, as I said, sometimes you want things 12, 24 months in advance. You don't want to have to wait. You need that information quickly. Home builders want to know, did Farmer Jones sell to real estate developer Smith? They want to know who has that land under development. And did that developer sell to Lennar or KB Homes or somebody like that? So we took these 5 factual indicators and we created a model. I worked with our data scientists. They said, look, take the 5 factual indicators, look at space and time, look back 3 tax rolls, come up with a model that gives me a predictive model, a probability model where growth is likely to occur. We weighted the model towards new construction permits and the new construction sale date, so it's kind of a lagging indicator. And then we came up with a growth score. This is the model logic. I'm not going to go through it. Indicators go in, score comes out. we came up with what we think is a fairly good indication. Again, it's the difference between using the factual indicators. And if you're a data scientist, you may want to go and chug along with that data and analyze it all you want. But sometimes you just want the answer. And what we have found is that not everybody employs 100 data scientists. They just have, some guy who's a GIS guy in the back room. They just want the answer. And that's why we came up with the model. So simplified, the model takes 158 million properties in the United States. We track that. That's what we do. And we come up with a growth score. We reduce the population to about 9 million properties. Now, that's still a lot. And some people are not used to looking at a lot of properties, but we've tried to isolate it as much as we can. So we're using Cardo in our analysis. We're looking at a couple of counties. I think some of these were mentioned earlier. We're going to look at Wake County. We're going to dive in a little bit. And all we're trying to do is really reduce the amount of properties you got to go look at. So in a heat map, it provides it very well. In this case, we're looking at new construction sale dates. Obviously, in the Wake County area near Raleigh, it is growing. I live there. It is just incredible. And we're going to go down a little bit further. I'm going to go down right to the residential area. And this particular area looks like this. You can see some homes are built, some are under development, and some you get some forested land that has not been developed. We applied the model. There's the score in the lower left in the legend. Some areas are ranked high, and as you remember, in that area, there's already homes built. We think our model did a pretty good job of where it's high, but look at these other areas here. They come up lower, not no growth, but lower likelihood. So they come up a little bit less in our model, but we also know who the builders and the owners of that property are. Lennar Homes, obviously a huge builder in the United States, owns this piece of property, and I actually did a little ground truth, and I can tell you that they are building out this huge residential area. But over here we have Tryon Investment. I don't know if they're a real estate developer or what, but more than likely they're going to sell that land to Lennar Homes. So again, in our definition, we took our indicators, shoved them into a data science model, a little bit of machine learning in the process, and we're trying to come up with a probability of where development will be. So in conclusion, what we think we did is we found areas where there's growth in development, hopefully a little bit before ground gets broken. But the idea is to come up with the answer. And the answer should be what many people want to know is, where is the residential development? Who's building it? How big are the size of the properties? Who's the builder in the area? We're trying again to reduce the amount of time and effort that it takes a real estate person, a realtor, a telco, in finding out where growth is going to be. Thank you very much.